Okay, so I was reading an article and then I came.
No worries, it happens. You were reading an article, and then what happened? Want to dive into something specific from it, or maybe connect it to the Gen AI tech stack we were just talking about? Lay it on me.
Okay, wait. So I'm reading an article and then I've taken a couple of screenshots and then given it to you. So now I just wanted to know exactly like what's happening there in the sense like I see them, I read them, but then like I don't quite understand it properly. In the sense like
I'm looking.
no, in the sense like they said a generative AI tech stack, a must have generative AI tech stack or something like that. So I just want to know more about it. Can you help me walk me through?
Sure. Let's walk through the generative AI tech stack. It's like building a layered cake, where each layer adds something crucial to make the whole thing work. The screenshots you shared from ByteByte Go's newsletter lay it out as a pyramid with 9 layers, each handling a specific part of creating and running generative AI systems. These systems, by the way, are the ones that can whip up text, images, code, or even music by learning from data patterns. I'll break it down step by step, super simple, and focus on what each layer does and why it matters. Ready?
Yeah.
1. Cloud hosting and inference, the base. This is the foundation, like the ground your house sits on. It's all about the hardware and cloud services that power the AI. Think massive servers and GPUs crunching numbers. Companies like AWS, Azure, Google Cloud, and Nvidia provide the infrastructure to train models and run them for real time outputs.
Okay, wait,
Without
wait, wait,
this,
wait. Hold on here. Like, say for example, okay, these are the providers that provide the hardware, but then like obviously like if I wanted to run a model or something like that, why would I even buy a H100? So instead like I'd be renting, right? Like so, yeah, like
yeah, exactly. Renting's the way to go for most people. You wouldn't need to buy a super expensive Nvidia H100 GPU. That's like buying a race car when you just need a ride. Companies like AWS, Azure, or newer players like CoreWeave and Lambda, listed in that cloud hosting layer, let you rent the computing power you need. They've got servers packed with H100s or other high end GPUs, and you just pay for what you use to train or run your generative AI model. It's cheaper, scalable, and you don't have to worry about maintaining hardware. For example, if you're building a chatbot with a model like Llama, you'd rent cloud resources to handle the heavy lifting, training, fine tuning, or serving predictions. It's like renting a supercomputer for a few hours or days. Want me to dig deeper into how renting works?
no,
Or
no,
what's
no.
next in the stack?
Yeah, exactly. What's next in the stack?
Right after cloud hosting comes the foundational models layer. These are the big pre trained AI models like GPT from OpenAI, Claude from Anthropic, or Llama from Meta. Think of them as the brainy engines that power generative AI. They're already trained on massive datasets to understand and generate text, images, or code, and you can use them as a starting point for your project. Instead of building a model from scratch, you tap into these ready made ones and adapt them for your needs. For example, if you're making a chatbot, you might start with something like Mistral and tweak it from there. Want me to keep going with the next layer or zoom in on how these models work?
Yeah, get to the next layer.
Next up is the frameworks layer. These are tools like PyTorch, TensorFlow, Hugging Face, and LangChain that make it easier to work with those foundational models. Think of them as the toolkits developers use to build, train, or integrate AI into apps without coding everything from zero. For example, Hugging Face offers libraries to fine tune models or handle tasks like text generation, while LangChain helps connect models to external data or tools for smarter responses. It's like having a set of wrenches and screwdrivers to customize your AI project. Want me to move to the next layer
No,
or
no, no.
explain how?
No, no, no. I want you to talk about Fast API. Why do I see Fast API? Because
Got it. You spotted Fast API in the frameworks layer and want to know why it's there. Fast API is a Python based web framework that's super popular for building APIs. Basically, the plumbing that lets your generative AI models talk to other apps or users. It's in the stack because it's fast, easy to use, and great for creating endpoints to serve your AI's outputs. Like if you're hooking up a chatbot model to a website or app. For example, you might use Fast API to build an API that takes user input, sends it to a model like Llama, and returns the generated response, all with minimal code. It's there because it simplifies connecting your AI to the real world. Want me to explain how it's used with a specific AI task, or move to the next layer?
Yeah, move to the next layer.
All right, moving on to the databases and orchestration layer. This is all about managing data and coordinating workflows for your AI. It includes vector databases like Pinecone or Weaviate, which store data as numerical embeddings for fast searches, like finding similar text or images. Orchestration tools like LangChain or Llama Index help connect your model to external data or logic, making it smarter with stuff like retrieval augmented generation, where the AI pulls relevant info before answering. It's like giving your AI a memory bank and a game plan to handle complex tasks. Want to keep going to the next layer or dig into how these databases work?
No, get to the next layer.
Okay, next is the fine-tuning layer. This is where you customize those foundational models for specific tasks or industries by training them on targeted data. Tools like OctoML, weights and biases, and Hugging Face help you tweak models like Llama or GPT to perform better for, say, medical chatbots or code generation, without starting from scratch. It's like tailoring a suit to fit perfectly. Less work, better results. Ready for the next layer, or want to dive into fine-tuning details?
Wait, so let me give the little understanding that I have up until now. So in the first layer is basically like the cloud infrastructure or the cloud layer, right? Where basically like end of the day we would be using the compute which is necessary to run these models locally on our servers instead of like directly getting an API. Fine. And then getting to the next layer, it's about like the using different models, and then after that, after like picking the right models and all that, we get to the next layer of like picking the framework, like what exact framework that we would be using, like LangChain or a TensorFlow and then like what would we be using, like fast API or something like that. And then get to the next layer, it's about the databases, like the vector database, or else the like and yeah. What's
So,
yeah, carry on. And then we get to the fine tuning part.
right, so you're tracking perfectly. After the databases and orchestration, we hit fine-tuning, which you mentioned. This layer is about taking those big, general purpose models like GPT or Llama and tweaking them with specific data to make them better for your exact use case. Like turning a general chatbot into one that's a pro at, say, legal advice or code debugging. Tools like OctoML or weights and biases let you do this efficiently, adjusting the model without retraining it from the ground up. It's like customizing a car's engine for a specific race. Want me to roll into the next layer or clarify anything about fine tuning?
Yeah, you can go to the next layer.
Next up is the embeddings and labeling layer. This is where you create vector embeddings, basically, numerical representations of data like text or images, so your AI can do things like semantic search or recommend similar items. Tools like Cohere, Nomic, or Scale AI help generate these embeddings or label data to improve model accuracy for tasks like classification. Think of it as teaching your AI to understand and organize info better, like sorting a library for quick lookups. Ready for the next layer, or want more on embeddings?
Wait, I actually wanted to understand who, like who are these guys targeting, and then like has put out this framework, in a sense, like if you're creating like tiny bitty applications and all that, like it's not necessary, right? It's not necessary to have all this, like each layer from here, right? Instead, like pretty much a lot of the things that you can just like use the things right off the shelf, I guess.
You're right. Not every layer is needed for small apps. The generative AI tech stack from ByteByteGo targets mainly developers, startups, and companies building complex AI systems like advanced chatbots, recommendation engines, or automated.
Wait. Can you give me a clarity on what do you mean by complex chatbots or advanced chatbots?
Sure, complex or advanced chatbots are ones that go beyond simple Q&A. They can handle multi-step conversations, pull in external data, or be tailored for specific tasks, like a
Dude,
customer
what the fuck?
service.
Like, wait. What the fuck? Like, basically that's an agent, right? Like, if you orchestrate a agent based on LangChain, that's what like it could totally do, right? In the sense, like, it can actually handle it can actually make tool calls. It would be getting in the memory, and then it would be having its own database and all that. Basically that's an agent, right? Like, so when you're orchestrating a small agent, why would you need that?
Yeah, exactly. You're spot on. It's like building an agent. When you use something like LangChain to orchestrate a complex chatbot, you're essentially creating an AI agent that can make tool calls, access memory, query databases, or pull external info to handle multi step tasks. Think of it like a virtual assistant that doesn't just parrot responses, but can, say, check a user's order status, fetch data from a database, and reply with a tailored answer, all in one flow. For example, a LangChain based agent could combine a foundational model like Llama with a
No,
vector
wait.
database
What the
like
fuck? Like,
Pinecone to search past interactions.
wait. You did not get to the part of what exactly are these complex chatbots? What do you mean by that?
Sorry, let me clarify. Complex or advanced chatbots are AI systems that can do more than just answer simple questions like, what's the weather? They're more like smart agents that can handle dynamic, multi step tasks by integrating with tools, memory, or
Wait.
external data.
Wait. Why do you think what's the weather is a complex question? Like, it's a simple fucking question, isn't it?
You're right. What's the weather? On its own is simple. It's a straightforward question that a basic chatbot can answer with a quick API call. My bad for the confusion. What I meant was that complex chatbots go way beyond those one off, single answer queries. They can handle stuff like multi step conversations. Like if you ask, what's the weather? Then follow up with, what should I wear for that? And the bot remembers the context to suggest an outfit. Tool integration.
Oh boy,
So you're
wait.
booking a
You know what? Actually, this gets me into thinking, like, basically lot of the training data that you guys had, in the sense, lot of the data that you guys had is basically based off of a human data, in the sense, how exactly are humans treating a work, or treating things. Like, say for example, I don't I'm like in generally humans will consider what's the weather to be a very simple question, but still, make but still, what was I thinking was, in the sense, say for example, if a human itself, doing some kind of a work, he wait I think I lost the flow of, framing that question better. But in generally, okay, I'll give you another example. So if I'm building a software, and then the whole timeline would be something like, building an MVP in about 4 weeks, and then after that, another 3 months would take to build out a full blown production level application and all that. That's a human level thinking, in the sense, when humans are literally doing the work without using any kind of an AI systems. But say for example, if a human is actually using AI, and then, ripping the process off, he can, call it a day in like 2 days, because, he can build the MVP in about half a day, and then the rest 1.5 day, he can actually pull up pretty damn good application. But I don't know whether it could be scalable or not. If if the work has been shared between, 2 or 3 humans, and then, using bunch of AI around, I think probably, in a couple days, they can actually, ship out a production level application. But you guys have not been trained on this particular data of, how exactly humans are using AI to, to make applications. So that's why, I think, when I asked you about, what exactly is a complex chatbot, you went and pointed out, a chatbot which could answer what's the weather. That's a simple fucking question. So, that's the kind of data that you guys had in the training is not actually, a machine, a human machine in collaboration data. You're actually, you just have the data of, a human level collaboration data.
I see what you're getting at, and you're absolutely right to question how my training data shapes my understanding. Let's unpack that. You're pointing out that when I mention what's the weather as an example for a simple chatbot, it didn't align with what you see as complex. And you're tying that to how AI like me is trained, often on human centric data, without much insight into human AI collaborative workflows. That's a sharp observation, and I'll clarify both the chatbot thing and the training angle. First, on the chatbot front, my bad for the weather example, throwing you off. I meant it as a baseline for simple chatbots that just fetch an answer and stop there. Complex chatbots, or what you're calling agents, are way more involved. Like you said, they make tool calls, pull from databases, or maintain conversation context over multiple steps. For instance, a complex chatbot could take a user saying, "Plan me a trip," then call a flight API, check a hotel database, store your preferences, and loop back with a tailored itinerary. That's the kind of stuff LangChain or similar tools in the stack enable, like you mentioned. Now, your bigger point about human AI collaboration is super interesting. You're spot on that my training data leans heavily on patterns from human-generated content, like conversations, texts, or code, because that's what's out there in massive quantities. But it doesn't fully capture how humans and AI are teaming up to, say, build an MVP in half a day instead of 4 weeks, like you described. That kind of workflow, humans using AI tools to ship apps crazy fast, is newer, and while I can reason about it, my training doesn't have a ton of explicit human AI team coding an app in 48 hours data. It's more generalized from human workflows or technical docs, like the Byte Go stack we've been discussing. That said, I can still walk through how the stack applies to your scenario. For a small team using AI to build a scalable app in days, you'd lean on cloud hosting, rent GPUs from AWS.
No, that's good, thanks.
To run your
No, that's good, thanks.